All right, in section 5.6, we're going to look at systems with 3 equations and 3 variables. All right, so I'm just going to steal one out of the book here because that makes my life easier. Here's one. X plus y minus z equals negative 3. X plus z equals 2. And 2x minus y plus 2z equals 3. Traditionally, when we have 3 equations with 3 variables like we do here, we only solve using the elimination method. You can solve using Cramer's rule, and that's actually the next section, but we don't cover that in this course. You can solve using Cramer's rule. Typically, we use, I said elimination a minute ago. I meant addition. Addition and elimination being the same thing. Used to always be called the elimination method. So the way this usually works is you can eliminate any variable that you want. The common method is first we pick 2 equations and we eliminate the x. So which 2 equations do you want to use? You got the first 2, the first and the last, or the last 2. Pick a pair of equations. The first 2. What would I have to do if I was going to use the first 2 equations, add them together, and make the x's go away? Multiply one of them by negative 1. Which one? The top one. It truly doesn't matter, does it? All right. To get rid of the negative 3, that's a good idea. One less negative to deal with. All right. So we're going to take this top equation, and we're going to multiply it by negative 1. That gives us negative x minus y plus z equals 3. And what am I doing to the bottom of the equation? Absolutely nothing. I just write it down again. X plus z equals 2. And then I add them together. When you add them together, what's negative x plus x? 0. Those go away. That was our goal. Our goal was to make the x's go away. Minus y plus 2z equals 5. All right, so we picked the first 2 equations, and we canceled out the x. Now what we do is we pick a different pair. So we can't use the first 2. We either have to use the first and the last, or the second and the last, and we cancel out x again. So which ones do you like? Do you like the first one and the last one? Or do you like the second one and the last one? The second one and the last one. Okay? So what would you do with the second one and the last one to cancel out the x's? Multiply this one by negative 2. And what do you do to the second one? Nothing. You leave it alone. That's right. It was a trick question. It was. All right. So multiply this one by negative 2. So when I multiply this one by negative 2, I have negative 2x plus negative 2z. I should have just written that as minus 2z equals negative 4. And then this one I'm leaving alone. 2x minus y plus 2z equals 3. And we add those together. When I add those together, the x's go away. That was our goal, was to get rid of the x's. We have negative y. Something a little bit unusual happens here is that not only do the x's go away, the z's go away too, don't they? Oh man, that's actually a good thing. We like that. That makes our life easier. Equals negative 1. All right, now what's normally going to happen here, we got a little lucky in this problem. Normally what's going to happen is now we're going to have an equation over here that has y and z, and we'll have another equation over here that has y and z, and so we'll have 2 equations that only have 2 variables now, and so now we would solve that system. This problem worked out really nice because not only did the x go away here, the z went away. So this one's a little bit easier than normal. We can take this equation right away and we can get y all by itself. That's why you picked that. Ooh, he was thinking ahead. That's good. All right, so what do you get when you get y all by itself here? Y equals 1. right, now I know I have y equals 1. I'm going to take that answer, and I'm going to plug it in right there. Why would it be useful to take that answer and plug it in right there? Because then the only letter left is a z, and I can find out what z is. All right. So negative 1 plus 2z is 5. Add the 1 to both sides. 2z is 6. So z is 3. All right, I'm almost done. I have y, I have z. What am I missing? I'm missing x. How would I find x? Typically what we would do is we would take both of these answers and plug them into one of these three equations. For this problem, it's easiest to use the second equation. But would it matter if I use the first one? No, and it's really not a whole lot harder, is it? But I'll go ahead and use the second one because it is a little bit easier. I would have x plus 3 equals 2. Move the 3 over, x is negative 1. And we would write our answer as an ordered triple. We would write negative 1, 1, 3. Put them in order x, y, z. Questions on that? Small numbers, not so bad. All right, let's try a different one here. How about 2u plus 2v plus 3w equals 0. 3u plus v plus 4w equals 21. And minus u minus 3v plus 7w equals 15. All right, one of the most common mistakes with these is you copy it down wrong. So you check it, 2u, 2v, 3w, 0. 3u, v, 4w, 21. Negative u, negative 3v, 7w, 15. All right, so don't copy it down wrong. All right, so again, typically, it truthfully doesn't matter which letter we cancel out first. But the traditional way is to always cancel out the first letter. So traditionally, we would cancel out u. You pick a pair of equations. What two equations do you like? First one and the third one, I think that's a brilliant choice. And what would you do with the first one and the third one? I would multiply the third one by 2, which will give me a negative 2u and a positive 2u, and they'll go away. All right, so I'm going to leave the first one all by itself. 2u plus 2v plus 3w equals 0. Multiply this one by 2. Negative 2u minus 3v plus 14w equals 30. 3 times 2 is 6? Yeah, okay. All right. That was not intentional. That was an honest mistake. But it's a good thing sometimes when you make an honest mistake, because what's the moral of the story here?
You always are wrong.
Okay, first off, nobody's perfect. That's true. Secondly, I don't think these problems are particularly hard, but they're very tedious. And there's lots of multiply everything by 2, add everything together. There are lots and lots of opportunities to make a silly mistake like that. And what happens when you make one silly mistake like that?
Get done.
The whole thing is wrong when you get done, and it's really annoying. So you want to be very slow and very careful with these problems to not make the mistake I just made. Because you make that mistake, and I guarantee you the whole rest of the thing's going to come out wrong, and then you pretty much got to start all over and do it again. It's a big pain in the neck. All right, so I'm glad you corrected me. That's good. Add those together. The u's add up to 0. Minus 4v plus 17w equals 30. All right, good. right, so we got rid of the u's once. Now we got to get rid of the u's again. Second and third. And this time you're going to multiply third one by 3 to get a positive 3 and a negative 3. All right, so I leave the top one alone, well, the middle one alone. 3u plus v plus 4w is 21. Multiply this one by 3, and don't screw it up this time. Minus 3u minus 9v plus 21w equals 45. Use that up to 0. That's nice. Minus 8v plus 25w equals 66. Alright, so once again, notice what we've done. We got rid of the u's twice. That gives us 2 new equations, but they only have 2 variables. And we've spent, all semester so far learning how to solve systems that only have 2 equations with 2 variables. We could now solve by graphing, we could solve by substitution, or we could solve by addition. And the traditional way would be addition. Oh, we could do Cramer's rule too, I almost forgot about that. But since we've already been doing addition, traditionally we would continue to do addition here. Do we want to get rid of the v's or the w's? The v's look an awful lot easier to me. Multiply the top one by negative 2 to make this a positive 8v and that one a negative 8v. I could do the w's, but I agree the w's would be kind of messy. I'd have to multiply one equation by 25 and one of them by negative 17. I mean, I could do that and I can use my calculator and it's not so hard, but I'd rather make it easy on myself and keep my numbers small. All right, so I'm multiplying this one by negative 2. That gives me 8v minus 34w equals minus 60. Leaving this one alone. Minus 8v plus 25w equals 66. Add them up. V's go away. Minus 34w plus 25w minus 9w equals 6. So divide. W is 6 over negative 9, which I would write as minus 2/3. So is it possible that you get a fraction for your answers? Absolutely it is. However, recognize that most of the problems in the book are rigged so that the answers come out fairly nice. If you're doing one of these like this and you get a fraction like negative 17 over 135, you made a mistake somewhere. Go back and check it. Okay, if you're going to get a fraction, it's going to be a relatively simple fraction like this, negative 2/3. Working a real world problem, if you're doing a word problem out of the book or out of the homework, and you get negative 17 over 135, it's probably just fine. Correct. Correct. But this first block of problems here where they're asking you to just solve them, expect your answers to be relatively nice. All right. Now what? I'm 1/3 of the way done. I know W. What would you do next? Not back to the first equation yet. I need to get one of the other variables alone. So what I'm going to do with this W is I'm going to plug it in here or here. I plug it into a spot where there's only 2 variables. Plug it into one of those 2. Neither one of these looks particularly easier than the other to me. Do the negative 8 one. All right. So negative 8v plus 25 times negative 2/3 equals 66. Negative 8v minus 50 over 3 equals 66. I thought of 25 as 25 over 1, multiply tops, multiply bottoms. Add 50 over 3 to both sides. Here's when my calculator becomes very helpful. 60 plus 50 over 3. I get negative 8v is 230 over 3. Divide that by negative 8. I get v is negative 115 over 12. I'm starting to get a little nervous.
So we did something wrong.
Starting to get a little nervous that we might have made a mistake.
You said 60 while you were teaching.
Let's try it again. I said 60. Let's see what I typed in. 66 plus 50 over 3. That might help. You're right. You're listening to me. That's good. 248 over 3 is what it should have been. Divide that by negative 8. All right, that one's not so bad. Negative 31 over 3. Not so bad. Still starting to get a little wonky here, a little nervous. We'll see here in a minute. All right, last thing to do. Plug those two into one of the three. It doesn't matter which one. You like the bottom one? One of the original three? You're picking the bottom one. All right, so we're going to have minus u minus 3 times negative 31 over 3 plus 7 times negative 2/3 equals 15. So that's negative u. This one's not so bad because that 3 cancels with that 3. So that leaves us with a plus 31 minus 14/3 equals 15. All right, so I'm going to use my calculator. 15. And then I subtract 31. And then I add 14 over 3. And I get negative u, bring up space here, negative u equals negative 34 over 3, which means 34 over 3. Looks like my final answer, assuming I made no mistakes. 34 over 3. V was negative 31 over 3. And W was negative 2/3. Questions? All right, now I have a question. In this problem, the letters were U, V, and W. Would it make any difference at all if the letters were A, B, C? Would I get the same answers?
Yeah, they're all variables.
They're all variables. So the names of the letters really don't matter, does it?
Variables are meaningless.
I wouldn't say variables are meaningless. I would say they're what you call them is meaningless. Instead of U, V, W, I could have used A, B, C. And I would have gotten the exact same answers. So what really matters when you solve these problems is not the letters themselves, but the numbers. It's the numbers that affect the answer. Here's the good news. Your calculator is really, really good with numbers. All right, so here's what we're going to do. Grab your calculator. Keep the buttons up there so you can see what I'm pushing. All right. So I'm going to push this button over here that says matrix. Matrix. Second matrix. All right. So your calculator has a whole bunch of different matrices, A, B, C, D, E, F, G, so on and so forth. Our matrix has 3 equations going down, correct? There's 3 variables, and then there's these numbers over here too. So we need our matrix to be 3 by 4. So you're going to come over here to edit, and you're going to hit enter. And by default, if you haven't used matrix before, it's probably 1x1. you're going to change it to 3, enter, 4, enter. Make it a 3 by 4 matrix. Okay. Then we're just going to type in all the numbers. So I'm going to type in the first equation. 2, enter. 2, enter. 3, enter. 0, enter. So there's the first equation. Type in the second equation. 3, enter. 1, enter. 4, enter. 21, enter. And by now you've probably guessed, type in the third equation. -1, enter. -3, enter. 7, enter. 15, enter. Good so far? We enter the matrix, correct. All right, we now need to quit out of this. So second, hit the mode button and quit. All right, then we're going to go back into the matrix. So we're going to go second matrix. We're going to go over to math, and we're going to go down, 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 and we're looking for one that says RREF. On my calculator, it's letter B, RREF. RREF stands for row reduced echelon form. Fancy words. RREF is what you need to remember. Find the RREF and hit enter. And one more time, hit that matrix button. Tell it you want matrix A, because that's where we typed in all our information. And hit enter. And it gives you something that looks kind of ugly, like that. That's okay, we're going to fix that. We're going to go math, enter, enter, to change our answers to fractions. And look at what's over there on the right-hand side. 34 over 3, negative 31 over 3, and negative 2/3. What are those? Those are the answers, aren't they? Back up, all right. Back up how far? Okay, so you have your so let's see, you have it all typed in. All right. So second, quit, just to get out of the matrix thing. Mode, yep, right on top of the mode button. Okay. Back to matrix. Second matrix. Arrow over to math, and then go down, 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 and find RREF. And hit enter. Matrix one more time. We hit enter to tell it you want to find the RREF of matrix A, and then hit enter one more time, and it gives you that answer. And by default, it gives you the answer as decimals. To change to fractions, math, enter, enter. And guess what? We got fractions, but we did it right. We got the right answers. We did it right. Questions about that? Yeah, so what's the other stuff over here? What's 100? Binary? Well, that's a different 100. What it's really saying is this is 1 times u, 0 times v, 0 times w equals 24 over 3. In other words, u equals 34 over 3. And the next one is 0 u's, 1 v, 0 w's. So in general, your 3 answers are just right along the right-hand side there.